Dear friends, welcome to the next problem of gears, say problem number 9. The data of the problem is like this. Two gears wheels having involute teeth are in mesh and have a velocity ratio of 1 by 4. The pressure angle is 14.5 degree. The arc of approach is not to exceed the circular pitch. Determine the minimum number of teeth on each wheel to avoid interference. Also find the addendum of the wheel in terms of circular pitch. Assume the smaller wheel to be the driver. Dear friends, let us note down the given values in the problem. Here the velocity ratio is given, that VR is equal to 1 by 4. The pressure angle is given, phi is equal to 14.5 degree. The arc of approach is not to exceed the circular pitch, means maximum arc of approach is given is equal to circular pitch. Determine the minimum number of teeth on each wheel. So we have to find out T, that is number of teeth on gear, and small t, number of teeth on pinion. Also we need to find out addendum of the wheel in terms of circular pitch, means addendum in terms of circular pitch. Here it has been given that maximum arc of approach, that is equal to circular pitch. We can write each is equal to pi into module. So the maximum path of approach will be is equal to maximum arc of approach into cos phi, where phi is pressure angle, and that is equal to pi into m into cos of 14.5 degree. So that gives us on calculation 3.04 times module. Let us say this is relation number 1. Now let us prepare a diagram for the given condition. This is the line of centers, and let us say this is the line of action. This is center A of pinion. This is center B of gear. This is pitch point P. Let us say this point C, that is start of engagement, and this point D, that is end of engagement, and this point E and this point F. So here it has been given that the maximum path of approach is equal to PE to avoid the interference. Here this angle is equal to phi as well as this angle is equal to phi. This radius B to P is equal to capital R and radius P to A is equal to small r, that is the pitch radius of the pinion. Now from the figure, the maximum length of path of approach, it becomes PE. So it is given by, from the figure it is clear that it is equal to R sin phi. So we can write that maximum path of approach is equal to PE is equal to R sin phi. So is equal to pitch radius is equal to of the pinion m into t by 2 into sine of 14.5 degree. On calculation we found is equal to 0.125 times m into t. Let us say this relation 2. Now comparing 1 and 2, we found that .04 times module is equal to 0.125 times module into number of teeth on pinion. That gives us T, that is number of teeth on pinion, is equal to 24.32. So we can write that minimum number of teeth on pinion to avoid interference, small t is equal to 25. Also the velocity ratio is given that Vr is equal to, that is omega g divided by omega p, and that is equal to t upon t, small t upon capital T is equal to 1 upon 4, and that gives us capital T is equal to small t into 4, that is equal to 25 into 4 is equal to 100. So minimum number of teeth on gear to avoid interference, capital T is equal to 100. Also we can write that gear ratio capital G is equal to T, capital T upon small t is equal to 4, hence 1 upon G is equal to 0.25. Now we know that maximum addendum is given by AW max is equal to M module into capital T divided by 2 in bracket under root of 1 plus 1 upon G into 1 upon G plus 2 into sine square phi minus 1. Substituting these values in this equation, we found it is equal to 100 into T divided by 2 in bracket under root of 1 plus 0.25 into 0.25 plus 2 into sine square of 14.5 minus 1. On calculation, we found that A omega max is equal to 0.87 times module. Now we want to calculate this in terms of circular pitch. So let us put the M in terms of circular pitch. So 0.87 into pi into M divided by pi. So in calculation we found is equal to 0.87 upon pi into circular pitch. You can say PC, and that is equal to 0.278 times PC. This is the answer. Thank you.